Hi, everybody. We are going to talk about transformations of sine and cosine graphs. And I'm just going to forewarn you, this is kind of a long one. So the goals are to be able to graph a sine or cosine function. So we talked before about where a sine graph comes from. So it looks like a hill and a hole. That's the parent graph. And the cosine function looks like a big U. But now we're going to talk about amplitude, which is really just a vertical stretch, period, phase shift, so going right and left, and vertical shift of sine and cosine. All right. So just kind of a reminder of what the basic graphs look like. Now, FYI, this is y equals sine of x. Sometimes it's going to be written like this. Instead of an x, it's going to have that Greek symbol there for an angle. It means the same thing, so don't get thrown off by that. It's just the same thing as an x. All right. So before we did it in degrees, I think I will do this in radians this time. So this is 0, half a circle, full circle, but in radians. And remember before we kind of plotted a bunch of points? Well, we're not going to plot all the points for the parent graph. These are the basic graphs for a sine graph. We start in the middle of the graph, we end in the middle. And remember, the one period, one typical cycle lasts 360 degrees or 2 pi radians. Okay, so it's going to start at 0, end at 2 pi, start in the middle, end in the middle, and then the middle has a middle there. Sine goes up to 1 at the beginning, and it goes down to 1 at 3 pi over 2. That should be a 2 here. That should be a 2. So if we graph that, it's going to look like this. Okay. And again, we can do from 0 to 360. Now cosine also goes up to 1, down to 1. We will do this in terms of pi radians as well. 3 pi over 2. But this time with the cosine graph, it starts at the top, it ends at the top, and it bottoms out in the middle. It crosses the x-axis at pi over 2, which is the same as 90 degrees, and 3 pi over 2, which is the same as 270. But then this is what that graph looks like. Okay? Now, of course, if this were degrees, you know, it'd be the same thing. It would just be, instead of 2 pi, it'd be 360. Instead of pi, it would be 180. 0 is still 0, etc. Okay? So we just graphed it in radians. Okay? So amplitude. Amplitude means height. And it's the same as a vertical stretch. So notice here that if we have a 4 in front, that means a vertical shift of 4. So this 4 just means that it's going to go all the way up to a 4 here. Okay. So, you know, if you remember that with some other graphs, if we had a vertical shift, it would just, instead of going up to 1, it would go all the way up to 4, and for that matter, all the way down to -4. Okay? So amplitude is really just the same as vertical stretch. I'm going to write that down. Vertical stretch. And it's the number in front of the function. It's on the outside. So we're going to kind of put this all together in a chart, similar to transformations that we've done in the past. Okay, if you remember from the past, if you added or subtracted something at the end, that meant it was a vertical shift. which means it would move up and down. So moves up or down. Remember, if it's on the outside, it does what you think. So if it's plus 4, it's going to slide up to 4. So it's going to start at 4 instead of 0. If it's minus 4, it's going to go down 4. So just kind of exactly like you'd think. So I'm going to add that too. Does what you'd think. So both the vertical shift, that's on the outside of parentheses. And so is that 4. It's on the outside of parentheses. Both of those do what you think. Like if we're multiplying by 4, it's not inside parentheses. You would think when you multiply, it's going to get bigger. And that's what it does. It stretches by 4. Here, if it says plus 4, you would think it would go up 4. And that is what it does. Okay. These tend to be a little bit more challenging when it's inside the parentheses. But if you remember inside, just like before, inside goes right, left. It's a right, left shift. And just like before, it does the opposite of what you'd think. Does the opposite of what you'd think. Okay, so in other words, if it's plus 30, you would think it would go right 30, but instead it moves to the left 30 degrees. Okay, so it's just going right, left. One of the things we do with phase shift, one thing we can do is we can set equal to 0 and solve to find phase shift. We'll talk more about that later. Okay, right now we're going to talk about period. You know what? I'm just going to add one more thing to that phase shift, which is, remember, if this is typically it goes from 0, 180 to 360. I just want to mention if it's going to the left 30, remember then it crosses everywhere else 30 degrees earlier. So it's going to end at 330 and it's going to cross again at 150. So I just kind of want to point that out as well, where it stops and starts. Okay, now let's go on to period. So the period is the length of the cycle, okay? It's the length of the cycle. And again, it's kind of, this is implied parentheses there, so it's on the inside. So you would think, again, if you're multiplying by 2, you would think that it would stretch, but it does the opposite. So this is really the same as a horizontal shrink. Horizontal shrink. It's the same thing as that. I like to think of it as if we're, if that blue dotted line is a typical one, see this is one cycle, it's typically one cycle. Well, notice the red one is where the new cycle ends. So this one here, this new cycle, one of them ends here at 180, and then there's another one again here from 180 to 360. So one way I like to think about it is the 2 inside means there are 2 cycles where there was originally 1. Okay? Now this is how we can figure out the period. We can figure out the period by taking either 360 divided by B. Notice this is B, so this would be B here. Or if it's in radians, it's 2 pi over B. So if you look back to that red line, how long did one cycle last? So how long did this one cycle, I'm going to make this a little thicker. How long did this one cycle last? Well, it started at 0 and it ended at 180. It ended at 180. So again, we could have found the period. Since there's a 2 in front here, we could have gone 360 divided by 2 to get a cycle of 180. So one cycle ended up to be 180 degrees. We also could have done 2 pi over 2, which is a period of pi. Okay, so again, we're going to keep talking about this. So now we're going to put everything together here in one chart, and then we're going to do a bunch of examples. Okay, so this is kind of a fair amount of writing here as we fill it in. I'm going to add one line to this. I think I'm going to try to shift it up a little if I can. Okay, so we'll have to write kind of tiny here, but we're going to add one line to this, which is reflection. So notice we have A, B, C, and D, no matter if it's sine or cosine. And we're just going to talk about what each of those represents. So starting with A, that stands for amplitude. And remember, amplitude is just vertical stretch. Or you can think of it as the height of graph. Height of graph. Okay, and the way we find it is it's just whatever the letter A is. It's the number in front. Okay. I'm going to try to, well, I guess we'll leave it there. I went a little bit into my next box, but okay, so we're going to go on to the next letter here, which is B. And B is the period, and that is the length of the cycle. Length of cycle. And B is the coefficient. Coefficient, which is just the letter in front of, it's the coefficient of X. So this is, I knew I was going to regret going into that, but the period, like I said before, is equal to, you can either think of it as 360 over B, or you can think of it as 2 pi over B. Okay. I'm going to go on to the next letter here, C, which is phase shift. Phase shift shifts graph left or right. And we find it, I mentioned this before, but set parentheses equal to 0 and solve. So we'll try some problems like that in just a little bit. So you're going to do everything inside. So if it's B, X plus C, you're going to take the whole thing and set it equal to 0. And when you solve, that is the phase shift. Okay. Vertical shift, it shifts graph up or down. So D, you know, if it's positive, it goes up, negative, it goes down. So both of these are vertical, right? One is a stretch and one is a shift. One slides up and down. So both of those are on the outside and they do what you'd think. Both of these are right left, they're inside parentheses, and they do the opposite of what you'd think. The last thing I'm going to mention is just this one here, which is if you have a negative in front of A. So it doesn't really matter for the vertical shift. Don't worry about if it's positive or negative, because whatever the absolute value of A is, that's the vertical, or I'm sorry, that's the amplitude. But the negative in front of it reflects it. So it reflects it over the x-axis, okay? And it's a negative in front, negative in front. Okay, so that was kind of summing up everything. Now we're going to move on to some examples. So there's a lot of stuff here. This is kind of brand new stuff, so it's going to takes us a while to go through everything. Okay, so I'm going to look at this one here, and I see I have a number in front, and I have, that's it, just a number in front. So this is really just a vertical shift. This is a vertical shift. I'm sorry, stretch, 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 stretch. Which means that this is going to go up to 3 and down to 3. Nothing else is going to be different. Now, normally you would either be told to graph it in degrees or radians, or there would be another clue, and I'll show you what the clues are in just a minute. But in this case, we'll just do it in degrees. Let's see, we'll just do in degrees to start out with. And there's no phase shift. Nothing changed with the phase shift. There's no vertical shift. Nothing was added or subtracted to the end. The amplitude is 3, and there's no different period. Now, notice there's, an implied 1 in front of there, or there would be an implied 1. Normally we would go 360 over 1. Well, if there is just nothing in front of X or that implied 1, where the typical period is going to be 360. It's going to start at 0 and end at 360. So if nothing is different, that's what we're going to do. Okay, so remember with a sine graph, it starts in the middle, ends in the middle. The middle is the middle. Okay? And then it tops out here halfway in between. So I'm going to go up to 3, down to 3, and that is my graph. I'm not going to do all those other points in between, like when we plotted at 30 degrees, 45. No, we're not going to do that. We're just going to do those major points, beginning and middle, the top and the bottom. Okay, so the only thing that was different from your typical graph is instead of going up to 1 and down to 1, this went up to 3, down to 3. Okay, so -2 sine x plus 5. Okay, so here we have a vertical shift. I'm sorry, amplitude. I keep saying this is the amplitude. This is our A. So it's a 2. It's don't worry about the negative. Amplitude is 2. This is the vertical shift. There's no number here. There's no number in front. So that means our typical period is either 360 or 2 pi. So once again, there's nothing to indicate if we're going to do it in radians or degrees. I'll just do it in radians. So like you would be told either to do degrees or radians, or it's going to be obvious in another way. So the period, because we're going to do it in radians, is just 2 pi because there's no change in the period. There's also no phase shift. Nothing was added or subtracted in here. Remember, period and phase shift would occur inside parentheses, or, period would be the number in front of X. Okay, now this is the other thing I have to pay attention to is this is a negative. And remember, a negative means it's reflected. Means it's reflected. I'm going to concentrate on some of the other stuff first. So because this goes up to 5, this is a vertical shift. I'm going to see if I can move this because this is kind of tricky to get in, but I'm going to go up. We're going to go up to 1, 2, 3, 4, 5. Okay, because this is where the center of the graph is going to be. It's going to be up at 5. Because we have an amplitude of 2 from the middle, it's going to go up 2 from there, and it's going to go down 2 from there. So it's going to go up to 7 and down to 3. All right. But that's the only thing that's different as far as the limits of the graph there. So no matter what, no matter if it's reflected or not, we better put our radians on here, 2 pi, because this is a normal period. This is 3 pi over 2. Okay, no matter what, we're going to start at 0, end at 2 pi or 360, and the middle is in the middle. So we start in the middle, end in the middle is the middle, okay, of the sine graph. Now this is what's a little different. Normally I would go up here, right? I would go up here and down there, but it's reflected. So instead, my new points, I'm going to reflect it over the middle. If I reflect it down, this is my new point, and this is my new point. So this is my graph. It's going to be, instead of going up, and then instead of a hill and a hole, it's a hole and a hill. Okay? So I did my vertical shift. This is kind of like the midline here. And then from that middle line, I went up 2 and down 2. And then the only other thing that was different, because our typical period is 2 pi or 360, so that didn't change. The only other thing that changed is that it was reflected. Okay, so nope, that's not the one I wanted. Okay, so get this one here. So 3 sine, and then theta. Remember theta, this could be an x. So just think of this as an x. It's no different. If you want to rewrite it as an x because that Greek symbol bothers you, feel free to do that. Okay, so we're going to start out with the outside stuff that we've already done before. This is our A, so that is our amplitude. This is our D, that's our vertical shift. So we're going to go up 1. The period, notice there is no new number in front of theta or x. So that means there's no change in the period. So our typical period for sine is 360 or 2 pi. So we'll just say 2 pi because we're going to do this in radians. Now here, notice it told us to graph in radians, but even if they didn't tell us that, I would know because they were using pi, I would know to do it in radians. Okay, so we're going to go back here and do the phase shift. So remember with the phase shift, I can take, I'm going to use x. I don't like to use that symbol either. Remember, we set what's inside the parentheses equal to 0 and solve it. So if I add pi to both sides, this is my phase shift. Okay, so this is the new starting point. This is your new starting point on the x-axis. All right, now this is where it's going to end. It's going to end, let's see, where do I draw this 0? This is the ending point. It's going to end at the phase shift plus the period. That's where you can always find the end. So the phase shift is pi. If we add 2 pi, it's going to end at 3 pi. Okay, so now let the fun begin here. So we're going to start out first by just labeling this. So I have an amplitude of 3 and a vertical shift of 1. So vertical shift of 1 means that this is my center here. That's my center at 1. That's the midline, right? Midline. Now from there, we're going to go up 3 and down 3. So if you want to make these little dotted lines too, so from that blue one, I'm going to go up 3, which takes me to 4, and down 3, which takes me to -3. Okay? All right, so that's the up-down part. Now we're going to take care of this period and vertical shift, which is left-right. Okay? So this is where I'm going to start on the x-axis. I'm not going to start at 0. I'm going to start at pi, okay? And I'm going to end, I'm going to just highlight this. This is the start, and this is the end. So I'm going to end at 3 pi. So this is pi, 2 pi, 3 pi. And again, if I want to do some little borders around that, I'm going to start at pi. I'm going to end at 3 pi. So within this box here that I've made, that's where our graph is going to be. At least one cycle of the graph. That'll be one correct cycle of the graph. Now, at least we have this going for us, that it's not a reflected graph. It's just a regular sine graph. So in this box here, I'm going to maybe try to highlight it one other way, because this is the box we have now. We are going to start in the middle, end in the middle. The middle is the middle. We're going to go up. We're going to go down. And this is our graph. Okay, so just to check, it instead of hovering around 0, it's now hovering around 1. Instead of just going up 1 from there and down 1 from there, we've gone up 3 and down 3. And it starts at pi, ends at 3 pi. Okay, now, we could continue on with this. So if I continued on, this is, what it would continue to look like. But one shift is enough. Okay, I'm gonna stop here. I will start another video with more examples, but I'll at least take a break and stop here, and then we'll continue on in a second video if you would like to see more.